Hi guys, welcome back to the channel. Today we'll be diving into important select statements, and we will be diving into further more important implementations with other clauses such as where, aggregations and more. But in this particular scenario we will be going ahead and implementing a new database called employees. I plan to implement this database with the table employees, which has employee ID, name, department, salary, join date and an active session. So we'll try to implement that in today's video and try to talk about the different forms of select statements that can be implemented, and not just hurry moving towards the next form of use of clauses and more. So yeah, let's get started. So I am gonna create this new database called this python me, and I will be using this for the rest of the session. And let's hit the thunderbolt, and you can see that the message appears in the output action menu, where you can see that the database has been created, and right now in this session we are actively using our said database. So let's go ahead and comment this particular statement out, since we will not be needing it again. So let's go ahead and create the table called employees. So we'll write create table employees, and we will go ahead with the parenthesis, and always remember to end your SQL statements with a semicolon. Here we will define approximately 6 columns, and each of the columns will have a header title, employee ID, followed by the data type, and here we will assign a primary key format to this particular column, making sure that none of the elements here are skipped and none of them are duplicates, and therefore we are able to uniquely identify each row within this entire table or tuple. So we can go ahead and write the next one, which is the name. We'll write name varchar, and we'll assign character limit of around about, I suppose, let's go ahead with 25, and we will go ahead with the next. Okay, we'll write something like ename, and we will define department, and here we will give a varchar of same as before, maybe 25. And let's go ahead with the salary of the employee. We will write a decimal statement. Here, whenever we define decimal values, we are always supposed to give the entire allocated character limit, here 10, preceded by the decimal point. So we will basically give 8 proper characters which define the numerical values, followed by the rest of the 2 for those preceding decimal point values. So here that's why we have defined 10,2. We'll go ahead and define join date, and here we will have the data type date, and we will go ahead with an active session, and we will define it as true or false statements. So here we have basically defined this table, and to go back again, so this particular statement, or the first part of the statement, basically defines the new table called employees. The employee ID int primary key is a unique integer which is assigned for each employee. It also acts as a primary key, meaning that none of the 2 employees can have the same ID. The ename has a varchar value of 25, meaning that each of the employees are allowed to have 25 characters allocated for their names. Here the next statement is the department, which has the same as before, and we are now going ahead with the salary, where we basically store the salary value up to 10 digits in total with 2 decimal places. And the join date, okay, I see the problem here, I missed this. So join date basically shows the date when the employee was a part of, officially became the part of the company, and it's stored in YYMMDD format. The active, okay, we'll change this to eActive, since this is a special reserved keyword. This is a true or false flag which indicates whether this particular employee is currently active or not. we'll go ahead and hit the Thunderbolt, and you can see that in the action menu this particular table has been created. Now it's time to go ahead and populate special values into this particular table that we just created. For that, I will just go ahead and comment out this particular statement so that we do not reiterate re-execute that particular statement. So in order to go ahead and insert values into this employee, I already have some values. I will be pasting it in order for us to save some time. So here you can see that we will have to modify some of these here. So we'll write ename and eActive. So yeah, here as we saw in our previous video, we are basically going ahead and inserting 5 rows of data into our employees table. Here each row basically contains the values which are arranged in an order specific to the columns which we had previously defined. So here you have employee ID, ename, department, salary, join date in eActive. This is a small but a rich dataset which will allow us to test various SQL queries such as filtering, sorting and calculations and more. So here you can see that I have just given them a employee ID of 1 to 5, names which are random, and they have been assigned to specific departments spanning from HR, IT and sales. We have some salary values and an official date of joining which is in YYMMDD format, as well as an active status. So we will go ahead and hit the Thunderbolt, and you can see that our statement, as you can see over here, has been implemented, and this particular execution has basically affected 5 rows which exactly corresponds with our 5 rows we just inserted. Now we will go ahead and comment this particular statement out in order to prevent a re-execution of the same. So yeah, going ahead with the basic select statement, which we all might already be familiar with, is something like select star from employees. So we'll write something like, and go ahead with the semicolon. Here the select star or the asterisk symbol basically means that we are selecting all the columns from the table that we have defined here, which is employees. And here the segment from employees basically specifies the table from which we are retrieving this data. Here this query will basically retrieve all of the columns, since asterisk basically arbitrarily specifies that. So we'll just move this up so in order to make this more visible. As you can see, all the columns spanning from employee ID to the active session has been displayed along with all their rows. Always remember, in SQL the table basically follows a tuple format where each of the rows are a tuple and they are implemented within this tabular nature for ease of interpretation. Always remember, the best practice is to use select star. This is very good for development and quick testing, but whenever we are trying to fetch large tables, it would fetch too much information and you would not be able to manage that. So it's usually not recommended to just directly go ahead and implement such kind of statements. So but this is one of the most popular statements that almost all beginners know. So let's go ahead and we will try to implement this particular select statement in terms of some specificalities that we can go ahead with. Let's say instead of going with select star, we can basically go ahead and try to filter this across the table. Usually we would like to select specific columns. This is because the benefit is that you basically enhance your performance, security and get better clarity or clean data as output. So the performance wise, if we compare, we basically avoid fetching unnecessary data. From a security perspective, we basically prevent the exposure of sensitive columns such as passwords and salaries, which are usually not required to be known in a work environment or any other case. Moreover, in terms of clarity, it basically keeps your output clean and focused to a particular use case. So let's try to implement some of these aspects that we just discussed. In this case, let's go ahead with retrieving specific names and department columns only from this particular table. In this scenario, we will go ahead and write like select ename as well as followed by a comma, followed by the department column which we are interested in from employees, and we will go ahead with the semicolon, and we will hit the thunderbolt, and you can see that the output basically showcases only the two columns that we are only interested in. In this case, select basically is the start of the query, tells SQL that these two are the columns which are the name and the department, which requests or specifies these two columns from the table employees. So basically SQL goes ahead and pulls this data from this particular table. Now we'll go ahead and comment this out. This is one of the ways to maintain some form of history or track. You can do that in your actions tab. As you can see, I am guessing that you are also following this on MySQL Workbench. So this particular feature will help you to keep or maintain a track of all the particular commands that you have executed. We can go ahead and do the same in terms of the name and salary. We'll write something like this: from employees. Go ahead and hit the lightning bolt, and you can see that we basically have retrieved the two columns that we intended. One of the most interesting aspects of using select statements is that in select statements we can go ahead and use certain expressions in order to calculate salaries. For example, if we are interested in retrieving the sum total of an annual salary that an employee can reimburse or emburse in an year, so we can basically go ahead and write a particular expression for that. This kind of capability can be implemented through SQL. So we can go ahead and write select ename followed by the salary. Since we are only interested in calculating the annual salary, we will write salary times 12, and here we would like to display a column header, so we'll write salary times 12 as, and then the particular terminology that you would like to showcase as the column header. So we'll write annual salary from, and then the name of the table as usual, so we'll write employees, and once you hit the lightning bolt as before, you will see that you have basically gone ahead and calculated the total annual salary for each of the users or members of this particular data set. So you can see that there is this kind of a depiction or calculation which has been carried out in the background. So here salary times 12 basically multiplies the monthly salary by 12, and therefore we get the yearly salary, while as annual salary, which we just defined, is the custom name for this or the new terminology that we are using as the column header or an alias. This is known as the alias section. This basically does not modify the original data, it only showcases it as a calculated value. Your original data still remains the same. So yeah, we can also go ahead and calculate different things or operations. Let's say you would like to add a bonus of 1000. You can go ahead and do the same, like doing something like select ename salary plus bonus, let's say as maybe monthly bonus or whatever, depending on your statement. Maybe you can calculate tax or some tax deduction. So this is a different way of implementation that can be done with this form or use of select expressions. Let's say another form of implementation of the select can be implemented by the use of conditional logic statements such as the use of case. Now a case works like an if-else statement, which basically helps in setting up or categorizing certain rows into specific values based on certain conditionalities. Let's say in this case we are interested in implementing something like this that we see on our screen in the result grid. As you can see, we have basically gone ahead and performed some sort of a categorization of the salaries based as low, high or medium for each of the personalities that have been included in this data set. So we would like to go ahead and do that. So how would you go and do that? So here is where we basically go ahead with the help of this use of case in the select statement. So here we will go ahead and write select. We will try to break this down into a little bit more digestible way. So we'll write select ename, the department column. So these are the two columns that we would like to retrieve from the existing table, but now this is the third column which doesn't exist, so we have to basically implement the case aspect of this. The case is using an if-else conditionality setup. So here we will write case, you can write tab and you can write when your salary is above 70,000, then you will categorize it as high, and then you go to the next line and you will set up the next conditionality that we want. So you'll write salary if it is between 60,000 and 70,000, then we'll categorize this particular value as medium, else we will go ahead and directly set it as low. And here whenever you end your case, you want to specify the column header or the alias that you want to define. So we'll write end as something like, let's say we'll go ahead and write category or something. So yeah, and here we will basically end this entire thing as from employees. So yeah, let me just scroll this a little bit down so that you guys can see this a little bit better. So if you go up, scroll it a little down, yeah, so you can see that the setup basically looks somewhat like this. Here we are basically retrieving the first two columns as usual. However, we would like to get hold of the third calculated, we would like to establish the case setup. Here the case basically works as if-else conditionality, where we have defined the conditions or the categories as three values, which are high, medium and low. We have basically stated that when the salary is above 70,000, then it should be categorized as high. Therefore this basically checks if the salary is about 70k and therefore labels it as high. And this same logic is applied for the medium label as well, but here the structure is a little bit different because we are setting it up as a value which ranges between 60k and 70k and so on. If it is not satisfying either of these conditionalities, then the label is automatically applied as low. And here, as I have mentioned before, always end your case statements with end as, and you are basically defining the alias for that specific column which is being calculated, and you finally end your select statement as from employees. So I hope it is visible. It's a bit small window, but yeah, I guess it should be visible. And let's go ahead and hit the lightning bolt, and you can see that we have basically recreated the setup that we just wanted. So yeah, you can also go ahead and do the same with different forms of select setups. Let's say you would like to use case in a scenario where you would like to depict which employees are active or inactive, so we can go ahead and write that as well. So we'll write select ename followed by case. So here we would like to define when the column active, or here we are eActive is basically holds the true value, then you would like to categorize it as a label as current employee, or let's go ahead and write current EMP. Else we will write it as no, let's say suppose something like maybe like not active or something. And as we are going to end this, so we will write end as employee let's say status, some alias as such, and you will go ahead and write from employees, or the name of the table that you wish to apply this kind of a logic to. So you'll go ahead and write this and hit the thunderbolt, and you can see that you have effectively categorized your employees based as human readable text. So this basically helps you to get a better output, and this can be used in dashboard views or basically getting a quick summary of your views. So yeah, I hope you understood something today and you learned something new. So I'll meet you in the next one. Bye.